So, we just said the average cost is something that's visualizable because its slope at any given point is, think about the slope of the line that goes from the origin, 0, 0, to that point, and that slope will be the average cost. We do the slope thing when we're talking about derivatives because it's the best way to approximate a derivative from a graph. This isn't really the case for average costs. Average cost, I can just read off the coordinates and divide them. Trying to draw the slope and draw the line and then estimate the slope of that line is not a good way of figuring out what the slope of that line is, because the slope's easier to compute than it is for a derivative. But this whole Goldilocks thing where, hey, the marginal cost is the slope of the tangent line. The average cost is the slope of, there isn't a word for it, but the line that goes from the origin to that point. And you can compare them. And hey, look here, the average cost line is flatter than the marginal cost line. So at this point, we can say that marginal cost is less than average cost. So to lower the average costs, the thing we want to minimize. This, by the way, is supposed to be a total cost function. So to lower average costs, increase production. And this graph hits it at another point. If I think about what's going on at this point, I'm just picking this point so I can reuse the same line. Here, the average cost line is flatter than the marginal cost line. Here, the marginal cost line is steeper than the average cost line. So, at this point, at this production level, A is less than MC. To lower average cost, we should lower production. This one's too low, this one's too high, this is pushing us this direction, this is pushing us this direction. What does it look like when average cost is actually minimized? Well, remember, average cost is the slope of the line that hits the curve. If I imagine all the lines radiating out from 0, 0, I want to think about, among all these lines, what's the lowest slope I can get? I think about taking that line and tilting it downwards as far as I can and still hitting the curve at all. If I tilt it too low, we don't hit the curve at all. That would be a lower average cost, but there's no point to go find where that average cost is minimized. This is a thing that's hard to display, but the thing you want to do is imagine taking your ruler, undo some more. No, I did want to undo that one. Imagine taking your ruler, fixing one end of your ruler at 0, 0, and then tilting it down as low as you can go, and still hitting the graph. If I lock one end of my ruler here, and tilt it, how far down can I go and still hit the graph? I've got my clipboard on my laptop, and I'm tilting it down. The last place I can tilt it down and still see the graph is this line, which, when I drew it, was a little bit lower than the place it's supposed to be to actually hit the curve. Let me just scoop my clipboard up a scooch so that I can try and get it to actually show me hitting the graph. Hit this curve, this line. Is this gonna... No, don't. I've got the wrong... Get my pen out. Okay, one more try. This point, this curve, is among those curves as I tilt it down. Okay, I'm just going to add a dot here and say I'm just barely grazing the curve here. It's hard to draw on a tablet because your pencil doesn't actually touch the place where the ink comes out. This is, among tilting these, I've tilted the line from here down as low as I can and still hit the curve. And this place where we just grazed the curve, hey look, here, the marginal cost equals the average cost. Here's the minimum average cost. I didn't label the x-axis or whatever. But it looks like the average cost is minimized at q equals A little bit more than 300. That looks like 310. Anyway, I really like problems like this because it shows off a cool thing you're able to read off from a graph. There's two versions of this in the homework. I've given you a graph. Tell me at this point, what's the marginal cost, what's the average cost, which is bigger, what does that tell you in the Goldilocks? It's telling you should increase the Q or whatever. Or, I will hand you a graph and say, find the place where average cost is minimized. And when that happens, what you're doing is you're at 0, 0, imagining all those lines, like lock your ruler in place here, tilt it down as far as you can tilt it and still hit the curve. The lowest you can do it and still hit the curve, the place where you just grazed the curve, the fact that you are just grazing the curve means that at that point the average cost line is the tangent line, and that is the place where average cost is minimized. That's it for business optimization. That should be everything you need to do homework 2A. That should be due pretty soonish. I don't know. I'll post about dates in a separate Blackboard post. I guess I shouldn't make the video the place where that information is. Yeah, that's it for business optimization. I'm going to get all this stuff up on YouTube. Like and subscribe, I guess. Don't like and subscribe. I'll see you. I guess I'll never see you. Man, this whole thing's so weird. Yeah. Check Blackboard for more information. See ya.